What we're looking at here is a fairly standard indoor coil. Now, we used to call these evaporators, but when heat pumps came in, it could be either an evaporator or a condenser, so now we call them indoor coils. Now, this is an A coil for obvious reasons. The A gives a little more surface area to put in ductwork. You could put it in a smaller piece of ductwork and still have the surface area. It is copper tubing and aluminum fins. And we'll take a close look at those aluminum fins. What I wanted to show you here is these fins, they're quite close together. There are actually coils that have a certain number of fins per inch, and that kind of decides on what they're going to be used for. But this is for an air conditioning coil. You notice these fins, they're bonded to the copper pipe. They are not straight. So what that does is when the air passes through, it has to take kind of a tortuous route through those fins. So it strikes the fins several times on its way through, and that transfers heat better. It also increases the pressure drop across the coil, and there is a specific pressure drop for each of these types of coils. But that's what those aluminum fins do. You know, they increase the surface area and then they scrub the air as it comes through. Now let's take a look at the tubing. Okay, there's kind of a look at the copper tubing. It's just a bunch of U-bends in the back of this. And this is extremely thin tubing. It's hardened copper, and they make it real thin so it'll transfer heat better. Okay, here's a look at the other side. This is where the refrigerant comes in. It comes in through this liquid line. Obviously, this air conditioning coil is not in very good shape. It's been bashed around. It's scrap. And this is a suction line here. Now note, this suction line has 6 pieces of tubing coming to it. Okay, it's manifolded in here. So there's actually 6 coils in this thing. Because there's a lot of length in this tubing. I think if you stretch this out, you would have maybe 800 or 900 inches of coil. And there'd be too much pressure drop across that coil, plus it's 3/8 pipe, and we're going into a 3/4 suction. So they make a bunch of different coils in this thing. So they pipe it all so that we have a number of short coils. Okay, looking at the other end of the coil, we have these small pieces of tubing here. Now these are distribution tubes, and they're coming from a central fitting. There's 3 on this side and there's 3 on the other side. That distributes the liquid refrigerant to the coil. Okay, here's the fitting that it goes into. The liquid line's coming in here. The refrigerant is being restricted here. Now remember, this is a fixed orifice device coil. So there's a restriction inside here between high side and low side. And this is actually a replaceable part. I'll get into how that thing works in another video. This coil is also considered a 20-degree coil. And what it means is, because we got these 3 passes here, it's going to take about 20 degrees off of the air temperature. So if air temperature is coming in at say 80 degrees, it's going to come out at 60. So it's what we call a 20-degree coil. This is most common in air conditioners. Now I'm going to show you a couple other designs of coils, and you can see what they're like. Okay, this coil here is an all aluminum coil, and I'll get a little up closer to it. It's still an A coil like the other one was. It still uses a fixed orifice device, but it's entirely made of aluminum. So we'll take a little bit closer look at that. Okay, where our other coil had copper tubes, this actually has aluminum tubes. The end plate on the other one was steel. The end plate on this one is aluminum. This is also a little larger diameter tubing. Their design is a little different. Aluminum doesn't move heat quite as quickly as copper. Maybe that's the reason they made the tubing a little bit larger. But this was, Trane did this one. This is real common for Trane, is to use an aluminum coil. And they work as well as anything else. Okay, this coil here is a flat coil. Obviously it's vertical, condensate drain in the bottom. This just hooks up to the ductwork on the other side of here, and air just passes straight through it. These are not real common anymore because they take up quite a bit of space, where if you use an A coil it would not take up so much space. But they're still out there, and that would be called the flat coil. There are a couple other types of coils I don't have to show you. There is a W coil, which is obviously in a W shape, and there's a slant coil that is very similar to this one, except it's just angled like that. There again, you can get a little more surface area for the air to pass over. I think all these coils I've shown you are 3-pass. It means they have 3 sets of tubing in the coil, which is pretty common for these evaporators. There's a few of them out now that are using 2 to get a little bit more efficiency out of the equipment and just using a much larger coil. But anyway, these are all 20-degree air conditioning coils.